In this video, we are going to take a look at the different types of distance measures that we use in market segmentation and why. Market segmentation aims at placing consumers into groups with similar needs or behavior. In order to find groups of similar consumers, we need a notion of similarity or dissimilarity. Mathematically speaking, we call this a distance measure. Let's look at this table, which shows the percentage of time spent on different holiday activities by 7 imaginary tourists. Each row represents an observation, in this case a tourist, and every column represents a variable, in this case a vacation activity. Each person's vacation activity profile represents a vector, and we are interested in finding the distance between these vectors. So Anna's vacation activity profile is vector x1, and Tom's vacation activity profile is vector x7. Numerous approaches to measuring the distance between two vectors exist, and several of these are routinely used in cluster analysis and market segmentation. A good way of understanding this concept is in the context of geography. If we take two cities as our vectors, then the distance between them is the length of the air route in kilometers. But other measures of natural distance between two cities are equally valid. For example, the distance a car has to drive on roads to get from one city to the other. A distance measure has to comply with a few criteria. One is symmetry, as demonstrated by this equation. And another is the distance of a vector to itself and only to itself is 0. In addition, most distance measures fulfill the triangle inequality, which holds that if we travel from x to z with an intermediate stop at y, the combined distance is at least as long as going directly from x to z. Euclidean distance is the most common distance measure used in market segmentation analysis. Euclidean distance corresponds to the direct straight line distance between 2 points, and it uses all dimensions of vectors x and y and treats all dimensions of the data equally. Manhattan distance derives its name from the fact that it gives the distance between 2 points, assuming that streets on a grid need to be used to get from one point to another. Both Euclidean and Manhattan distance use all dimensions of vectors x and y and treat all dimensions of the data equally. They take a sum over all dimensions of either squared or absolute differences. If the different dimensions of the data are not on the same scale, for example, dimension 1 indicates whether or not a tourist plays golf, and dimension 2 indicates how many dollars they spend per day on dining out. The dimension with the larger numbers will dominate the distance calculation between the two observations. In such situations, it's advisable to standardize the data before calculating distances. With the asymmetric binary distance measure, similarity between two observations is only concluded if they share ones, but not if they share zeros. And dissimilarity between two observations is increased if one has a 1 and the other not. This has implication for market segmentation analysis. The fact that two tourists have in common that they do not bungee jump is not very helpful in terms of extracting market segments, because the overall proportion of bungee jumpers in the tourist population is low. If, however, two tourists do both bungee jump, this represents key information about similarities between them. The asymmetric binary distance corresponds to the proportion of common ones over all dimensions where at least one element is 1.